Welcome to our second edition of the EPS Techstars program. My name is Tritiman Hui and I'm a managing director at Techstars, and I'm proud to be leading our partnership with Eastern Pacific Shipping. Welcome also to a showcase of one of venture capital's last unexplored markets, the maritime industry. For the uninitiated, this industry earns and spends hundreds of billions of dollars each year. It is massive. It has ships on the water worth almost $300 billion, and it carries trillions of dollars of cargo each year. Markets and opportunities don't come bigger. Without any further ado, let me introduce you to, in turn, Gil Ofer, Principal and Special Advisor at EPS, and Klaus Nemzau, Chief Innovation Officer at EPS. Over to you, Gil.
Thank you, Dritman. When we started the Eastern Pacific Accelerator with Techstars 2 years ago, our intention was to find, invest in, and mentor the next generation of entrepreneurs who could potentially disrupt one of the most traditional industries in the world. We knew to achieve this mission, we could not do it alone. That's why our Accelerator program is based on a foundation of open collaboration and mentorship. In fact, we have seen hundreds of subject matter and industry experts provide invaluable guidance to our cohort. This open innovation strategy has two distinct advantages. First, it ensures that the industry moves forward collectively, and second, it ensures the startups solve real-world problems and have immediate commercial applications. I am personally excited about this year's cohort. This year we focused on startups that directly or indirectly impact sustainability and safety, which are top priorities at EPS. I am also proud of our entrepreneurs because they have found practical and scalable ways to modernize the industry, as you will soon hear for yourself. To discuss how they are doing this, I would like to introduce EPS's Chief Innovation Officer, Klaus Nemzau.
My name is Klaus Nemzau. I'm the Chief Innovation Officer here at EPS. And when I joined back in October 2019, I was really excited to work on the challenge for the maritime industry to drive innovation, because maritime industry still is behind other industries. Now, some of the obstacles like the connectivity on ships, those things are improving. But most importantly, we live in a perfect storm of technology, both on the hardware side and on the software side. On the hardware side, you see, driven by mobile technology, often you see things like sensors, gyroscopes, accelerometers, all those kinds of things developing very fast. On the software side, most importantly, things like AI, deep learning, are technologies that are developing not just in a linear but in an exponential fashion. And you see that these things empower each other. So AI in particular drives a lot of capabilities that allows robots to be more autonomous, and all those things really help to drive innovation. And I think what you see in the pitches from the startup companies from this year will be really exciting. You will see a cross-section of robotic companies, virtual reality, augmented reality, new types of materials, and all the sorts of things that will drive economics, reduce emissions, and help with health and safety for our seafarers.
Hey, my name is Christian. I'm the CEO of Kanda, and we're using elements from computer games to improve training of complex procedures across critical industries. Take, for example, an offshore wind turbine. Each of these can consist of more than 50,000 individual components, meaning it's more or less impossible for a single person to have a complete overview of this process. Therefore, trainings and introductions are a key part of being able to do this safely and effectively. We see the same challenges across other industries, such as the maritime, energy, or pharmaceutical sectors. If you contrast this by the way training is being done, and not all that much has changed since the first industrial revolution. Sure, the methods have changed, but the concepts remain the same. It's about bringing people to one location. Today, that's the classroom, and going through days on ends of slides. And if you're lucky, you'll finish off with some hours in a very expensive physical simulator. But because these simulators are so expensive, there's not that many of them, meaning there's also going to be spent a lot of time and money getting people to it. So it's both an expensive way of training, but also not that effective. What we created is a platform that allows for this type of training to be done either from home or during your normal day-to-day work when there's a natural pause in your work. Doing this, we're able to cut as much as 2/3 of the cost of delivering this type of training. And in some cases, we've even completely eliminated the need for this expensive physical replica, thereby cutting the cost of maintaining and operating the machine, as well as the travel cost of bringing people to it. The platform is available across a multitude of devices because we're not yet living in a world where everyone have easy access to a VR headset. So we need to make sure that people can access and complete this training from a device that is more readily available to them. Looking at the training, we see that it's important that people do this together. Very few assignments today are done by an individual. It's mainly group work, so training should be as well. And when people train together, we see that they're more motivated, they enjoy themselves better, and because of that, they remember better and for longer. Now, it's not a simple thing creating this type of scenarios. Often a single scenario can take hours to complete and involve hundreds, if not thousands of steps. So we've taken a page out from Walt Disney's old playbook and reuse as much as we can. We've created a system that allows us to reuse up to 70% of our code base and 20% of the models we're creating. And we're able to do this because we have years of experience on what works in different industries, what works across industries, and how are training done. And as we develop more and more content, this number is only going to increase. While it can be a complicated procedure to develop this type of training, we see that it has a very long lifespan, often as long as the machines that they're used to introduce. And because these trainings are so complex, it's often mandatory or certificate-based training, meaning people have to come back to it again and again for recertification. So that also means that the cost reductions we're seeing are not just a one-off, it's something that keeps coming back year after year. There's a lot of markets where this has a potential, but each of them have their own individual complications and their own industry jargon. So we've initially focused on 4 industries, that is the energy, maritime, aviation, and pharmaceutical sectors. And across the world, they employ around 76 million people. And we believe that we're able to cut the cost of delivering training to these people by up to 2/3 for every employee. These cost savings come primarily from 3 areas: reducing the need for travel and accommodations. And because more of the training is going to be done digitally, there's less of a need for constructing these physical replicas and renting the classrooms. This frees up quite a lot of time that people can spend on working or together with their family at home. And we're lucky enough that we're already working with innovation partners and key front-running companies across these industries to develop and deliver this type of training to market today. My name is Christian. I look forward to continue the dialogue and thank you for listening.
Hi, my name is Uri, the CEO of Captain's Eye. I'm a former Navy captain. I retired from the Israeli Navy after 27 years of service. Our story begins in the Red Sea, where I commanded on one of the operations in the Israeli Navy. I remember standing on the bridge, supervising the most important stage of our mission, and one of the officers reported that he sees smoke rising up from one of the generators. We immediately called the machinery control room and they dealt with the problem very fast. I thought to myself that such luck would not happen to us twice, and if the officer had not accidentally watched the smoke, it could done tremendous damage and failed the mission. In the shipping industry, it can be seen that ship size grew by 1500% over the last 50 years, and despite this, crew size has dropped by at least half. For a crew of 24 people, to keep a constant eye on every aspect of such large ship's operation is impossible. As a result, a lot of things can really get wrong, and let me give you a few such examples. Fires caused by cargo or engine failures. Ship carries all kinds of liquids. Most of them are very dangerous. Terrible leakages can happen and lead to other disasters and environmental pollution. Ships involve all kinds of dangerous staircases, climbing up things to inspect equipment. Accidents happen to crew all the time. If an accident happens to a crew member, it could go undetected for hours. When things go wrong on a ship, if you can catch it early enough, you can solve the majority of problems. If you cannot find problems early enough, you can lose a ship and cost in men lives and tens of millions of dollars. If something happens to the cargo, it can cost hundreds of millions of dollars. The shipping industry needs a technological solution that can detect events and immediately alert the crew. Captain's Eye provides an AI software which connects to installed simple cameras that detects automatically safety issues. In this example, smoke detected. The officers alert irrelevant personnel which quickly understand what the problem is, where the problem is, and can deal with it before it's too late. Problems on board a ship can get pretty complicated. It is impractical to expect crew to have the knowledge and the experience to deal with every single problem. Sometimes a lot of that experience is on land, in the offices of the ship's owner. Our solution helps connect the crew at sea with that experience on land to make sure problems are dealt with in a timely and in the best possible way. And this is not easy to do, and let me explain to you why. We have had to collect from our partners 10,000 of hours of video to train our algorithm. We have then had to help the algorithm to tell the difference between routine actions and bad actions with our deep know-how of the industry. We have then had to make sure that our algorithm does not give false positives. We cannot afford to let our system wake up the ship's crew in the middle of the night for no reason. And we have had to do this for hundreds of different kinds of ships, with hundreds of different kinds of operations. The permutations and combination to this are endless. In our target market, there are more than 100,000 ships, and this is without Navy vessels, which can get a lot of value using Captain's Eye. There are about 1,300 offshore gas rigs, almost 1,000 major ports, and more various segments in the shipping industry. With our special AI capabilities, we can for sure expand to other markets onshore in the future. The traction for our product is very good. We have 5 confirmed pilot projects with some of the Asia and Europe largest shipping companies who own many different kinds of ships. They own container vessels, oil tankers, chemical carriers, and bulkers. These are vessels with very complex operations. To get the support of such prestige shipping company so early in our journey, tell us we are on something special. One of the things our clients like the most about us is how affordable we are. We cost less than 0.04% of what their overall budget for running the ship. For the disaster that we can prevent and the operational expenses that we can save, it's nothing. Our team is very experienced. Doron, the CTO, is a colonel retired with 23 years of career in the Israeli Ministry of Defense Technology Unit. Doron is an R&D leader and directed vast technological programs. Our AI specialist is more than 30 years of experience in development of many computer vision-based systems. With this fantastic team, we will take forward Captain's Eye to improve the safety culture of the maritime world. From top to bottom, front to end, the Captain's Eye has your ship covered. Thank you.
Hi, this is Arpan. I'm the co-founder of Alicia Bots. We're a Boston-based robotics startup with an aim to bring robotics into the maritime industry. Before proceeding, I would like you guys to hold on to this alarming fact. The pollution caused by one of the biggest ships is equal to that caused by 50 million cars. And that is the scale of the problem. There are about 70,000 vessels in the world. One way of curbing the pollution is by making these ships burn less fuel. On an average, the shipping industry consumes 5 million barrels of fuel per day. And that expense adds up to $60 billion over a year. More than 50% of the operating cost in this industry is spent on fuel. This is why the industry is in constant search for making these vessels more efficient. One of the major reasons for fuel inefficiency is biofouling. So what is biofouling? The picture that you see shows a clean ship hull. The maroon portion sits underwater. If you leave anything underwater for too long, a thin film of green-colored microorganisms collects on it. You may have seen this green slime at the bottom of a swimming pool. Well, this may look innocent. It creates a lot of resistance as the ship cuts through the water. And as a result, a ship's engine has to work harder, and it ends up burning a lot more fuel. Let's illustrate this process of biofouling using a diagram of one portion of the ship hull. The biofouling process starts with a simple thin layer called biofilm. This increases the fuel consumption by 2 to 3%. If you don't get rid of it, another layer builds up on it called algae, and it burns 5 to 10% more fuel. Well, if you still choose to ignore, then another layer builds up on it called barnacles, which are extremely difficult to remove, and by this time, your fuel consumption could have gone up by 15 to 20%. That is a lot of extra cost for the ship. How much money this could end up costing a shipping company? It could end up reducing the profit by as much as 5%. That's more than $1 million per ship per year. This is substantial money. How does the industry currently fix this problem? Well, a diver goes underwater and physically scrapes off the biofouling. This is both time consuming and expensive. Also, it can only be done in ports. As a result, the ships end up getting their hull cleaned only once a year. Once a year isn't that often. As a result, biofouling keeps collecting on a ship's hull, and the ship ends up burning more fuel than it needed to. Do you recognize this place? This is a dentist clinic, and nobody likes to sit on that chair. If you brush your teeth every day and take care of your teeth, then chances are you wouldn't have to sit on that chair frequently. Similarly, if you clean a ship's hull regularly, you will never need to burn all that extra fuel and send divers underwater. But you can only clean a ship's hull regularly if you make it as affordable and easy as an electric toothbrush. And that's what we have done with our product Rover Clean. Rover Clean is so affordable, every ship can keep one on board. And it is autonomous, and it cleans the hull all by itself, if needed, once a month. There is no need for any human intervention, and it's completely hassle-free and easy to use. The key to this is making the solution affordable and autonomous. People have tried to do this several times, but they haven't been successful. They cost 5 to 10 times more than us, and they need to be operated by a human being. That's too much hassle. We trump our competition on both fronts because we are so much cheaper and autonomous. Best of all, the return on investment on this is fantastic. Something that costs less than $10,000 a year can save you as much as $1 million a year. We believe automation is going to play a key role in the future of maritime industry. And we want to be a part of it by being a robotics company dedicated to solving maritime challenges. Our vision is to launch a series of robots that can solve important day-to-day challenges in the industry. For us, 2021 is the year for hull cleaning and inspection robots. In the next 2 to 3 years, we are planning to launch other sets of monitoring and cleaning robots. Eventually, we plan on launching a perception robot. We envision a future where there will be multiple Alicia Bot solutions present on board. The maritime industry currently spends $45 billion on manpower. This manpower is based on ships and shipyards doing all kinds of routine tasks. We feel over the next 10 years, we can take a big chunk of that market. We have a long journey ahead of us. Right now, we have successfully tested our prototype rover Clean on a small boat. And the next step is to test it on huge bulk carriers. We have our expansion plans in the pipeline, and we look forward to successfully automating the maritime industry. Thank you.
Hi, my name is Sean Seaman, and I'm the founder and CEO of Mushroom Material. Now, this beach may look like it is covered in snow or sea foam, but it is actually polystyrene, commonly known by its brand name of styrofoam, and it is destroying our natural environment. You have all seen and used polystyrene. It dominates the packaging industry and has entered all stages of our lives, from the purchase of TVs and computers to glassware and cosmetics, and of course, takeaway food containers. On a global level, we currently produce enough polystyrene to cover an entire football field every 10 minutes, which means we cover 52,000 football fields with polystyrene every year. And if that's not scary enough, only 1% of that is recycled. The remaining 99% quickly finds its way into landfill, where it accounts for 30% of all landfill volume around the world. The problem with polystyrene is that it takes over 500 years to decompose. So the packaging you throw out today will still be in landfill in the year 2521, affecting the next 17 generations. And what doesn't go to landfill ends up in our oceans, where it is mistaken for food by marine life. In fact, plastic and polystyrene are responsible for 90% of the debris covering our ocean surface. Over time, this debris breaks down into microplastics, polluting our ecosystems, contaminating our waterways, and eventually ending up in the food we eat and the water we drink. Now, because this has become such a problem, governments around the world are banning single-use plastics, specifically polystyrene. There are currently initiatives in 25 countries backed by the United Nations policies against plastics. In the next 5 years, polystyrene will be banned in most of the Western world, which means we have 5 years to figure out a sustainable alternative to the $18 billion that businesses spend on polystyrene packaging every year. This is a tough task. Polystyrene has set the bar high, and to make it work, any alternative material must be able to tick all of these boxes. The packaging industry has spent decades and millions of dollars trying to find a solution, testing a whole range of potential candidates, from eggshells to hemp to cornstarch, but have continually failed. And this is what we at Mushroom Material are all about. We have developed a mushroom-based alternative to polystyrene which meets all these requirements. We do this by combining the root structure of mushrooms, known as mycelium, with agricultural waste to produce a completely biodegradable packaging material. Our material matches polystyrene's performance in vertical drop, static load, and impact testing, and it is fire resistant even to an open flame. The best part is that once it has served its purpose, it will naturally decompose in your garden or in landfill within months. Our company is only 6 months old, and we've already built a pipeline of 150 validated clients. 9 out of 10 brands we spoke to have joined our waitlist, and we're in the process of rolling out our first prototypes for customers in the cosmetics industry that we already have on board in Singapore and in New Zealand. Once we have successfully entered cosmetics, we will expand into appliances and later into building insulation. In total, we are looking at an $84 billion market. And this is a team of engineers that will make it all happen. I'm Sean. I've spent the last 7 years designing and developing consumer products across a range of industries. Jotinder is our automation expert with specific experience in testing and scaling mass production lines. James has spent the last 12 years managing projects and teams for large-scale manufacture of consumer products around the world. And that's us at Mushroom Material. Thank you for your time.
Hello, I'm Andrew Lowenstein, CEO of The Fuel Matrix. Our company makes a product that will help fleet owners and operators with one of their biggest challenges, reducing harmful emissions at sea. Every day, global fleets burn approximately 4 million barrels of fossil fuel, and this number is continuing to grow. That's the equivalent of about $60 billion of fuel. Unfortunately, that fuel creates 714 million tons of CO2, or about the equivalent that the entire nation of Germany releases in a year. Groups like the International Maritime Organization have already passed restrictive legislation limiting the amounts of harmful emissions at sea. Our product, Fuel Matrix, helps fleet owners and operators meet the IMO emission standards quicker and cheaper. Fuel Matrix is a liquid comprising ethanol and ionic compounds. We pass that liquid under an electromagnetic wave of a very specific wavelength and intensity, and the electromagnetism polarizes Fuel Matrix. When Fuel Matrix is added to fossil fuel in minute quantities, such as 1 part Fuel Matrix to 10,000 part fuel, that fuel is polarized. How does Fuel Matrix work? In a combustion chamber, liquid fuel is vaporized, and this fuel vapor is mixed with air. The hydrocarbon molecules in the fuel vapor mix with the oxygen molecules and create heat and energy. Unfortunately, air is about 21% oxygen and 79% nitrogen. The nitrogen molecules also try to combine with the oxygen, dampening combustion and creating harmful NOx. With Fuel Matrix, the polarized hydrocarbon molecules draw in the oxygen molecules, resulting in a more complete combustion. More complete combustion, in turn, means less fuel used per nautical mile, less CO2 emitted, and less greenhouse gases emitted. Fuel Matrix works fantastically on land. A bus fleet in Brussels showed over 15% fuel savings in a real-world test monitored by the University of Brussels. America's most prestigious environmental lab documented a 60% reduction in NOx with diesel fuel in a high-speed diesel engine. The European Lean and Green organization has certified that Fuel Matrix saves a minimum of 10% fuel in logistics vehicles. And finally, in Brazil, a bus company documented over a 95% reduction in particulate matter. That's the soot that causes black smoke. To bring Fuel Matrix from land to sea, we've teamed up with EPS and Techstars. Our program has 3 steps. First of all, we're testing Fuel Matrix together with marine gas oil in a laboratory in Belgium. Second of all, we're doing real-world testing on an EPS vessel in Texas. Finally, because emissions are so important, we're doing emissions testing with Ken Oil and the Nanyang Technical University in Singapore. The Fuel Matrix already has a presence in North America, Europe, South America, and Africa, and we're just starting to get involved in Asia. We have multiple use cases and customers across different industries, including fuel suppliers, agricultural groups, public bus fleets, logistics, and waste management. Our goal is to make a fundamental change in delivering decarbonization today. For more information on our company or product, please contact us. Thank you very much.
Hi, I'm Rohit Deshmukh, CEO of Siricon. We are based out of Singapore and we make industrial inspections simpler. This is an image of a ship that's as big as a giant stadium and is like a huge floating refrigerator carrying highly inflammable gas that's frozen to minus 160 degrees centigrade. You can imagine the complexity of the whole machinery and how risky the entire operation is. Given how complicated and risky shipping has become, the industry's regulators have put in place very high standards for safety and maintenance, which means a lot of compliance checks and audits. But the regulators aren't the only ones mandating these checks and balances. Shipping companies themselves regularly do checks and maintenance work to make sure that their ships are in tip-top condition. But despite that, things tend to go wrong. And when they go wrong, there are more audits and insurance claims. All of this translates into one thing: a lot of inspections. All inspections and audits are done manually, and this picture shows you how they are done. With a person hanging onto a ladder with both his hands 30 feet in the air, which can be dangerous. As you can see, there's not much scope for him to pull out a piece of paper and take notes while he's doing the inspection. We've all been to meetings where we've not taken notes, and we find it difficult to recollect the details the next day. And this is the struggle for all people doing inspections in the maritime industry. They have to do the inspection, take notes on paper, then come back to the office the next day, and then try and make detailed reports from memory. Given how manual this whole process is, the maritime industry alone wastes more than 3 million hours every year on inspections, making it expensive, often ineffective, and time-consuming. We at Siricon are revolutionizing the entire inspection process using wearables and AI in a way such that now their hands are free and it's safer, and allows the users to conduct these inspections using just plain speech. Every inspection is different and complex. For example, an engine room inspection comprises of 60 steps, and it's often difficult for the inspector to remember each step or keep on referring to paper checklists all the time. Our technology solves that problem. It shows you on the display lens each single step that has to be followed. So now no need to remember anything, just follow the commands that you see on the screen. And while you're doing that and going through the inspections, and you notice something that you'd like to record as an observation. So instead of taking physical notes or pictures or trying to remember, just look at the problem and talk. Our technology captures video and voice recordings and immediately understands the context around these recordings. Once you're done with the inspections, no need to undergo through a painful report writing process. Our system will automatically generate a report with notes, annotations, videos, analytics, and compliance information. Like I said, once you wear it, we'll take care of the rest. Now, it's impossible to have all the answers on board, but there are thousands of hours of experience at the office who manage these ships. The problem is that bandwidth is low at sea, and so coordination is an issue. One of our more advanced features is to connect the ship to the shore during inspections. And that's one of our customers who's trying to diagnose a problem at sea with the help of a technical expert at the shore office, which allows them to solve these critical problems in real time, even in low bandwidth conditions. This is the type of massive improvement that's needed for every ship in the world, which will save hundreds of millions of dollars for the shipping industry. Although maritime and oil and gas is our current focus, but field inspection is common to other sectors such as mining and construction who have the similar challenges. And we are already in discussions with a mining customer for their inspection needs. We've had a lot of interest from the industry. For example, Eastern Pacific Shipping and TK are one of the world's largest fleet owners. And we are also co-creating remote inspection standards with regulators such as DNVGL and Maritime Port Authority of Singapore. Between our clients and the companies in the pipeline that we are talking to, we can deploy our solution on any ship in the world, and we are confident of securing 3% ships of the global maritime fleet in the next 4 years. This, along with some traction in other sectors, firmly puts us on track to be a company with more than 100 millions in revenue. Thank you for taking the time to listen, and just let me know in case of any questions.
Hi, I'm Captain Roy Torgerson, the founder and CEO of Nemo Robotics. We make autonomous and semi-autonomous underwater robots, ROVs for short. Let me present you to Stan the seal. He's pretty cute, huh? We'll get back to Stan in a second. This is a salmon farm in Norway. It holds fish worth 20 to 30 million US dollars. There are currently thousands of salmon farms like this in operation in Norway, Chile, and across the rest of the world. Remember Stan? If you're a fish farmer, seals are a huge headache. Just imagine if you had someone who was constantly trying to break into your house. The problem with predators like Stan the seal is that once they've broken into your farm, they're having a feast costing you thousands of dollars, and they leave gaping holes like this one for the fish to escape. That's just one reason why salmon farmers like Aquachile spend hundreds of thousands of dollars every month employing hundreds of divers like Carlos here, in addition to teams of ROV operators with their robots. So far, I've spoken about the salmon industry, but truth is, it only represents about 5% of the global aquaculture industry, worth $300 billion. There are tens of thousands of farms out there waiting for us to deploy our robots in order to help them with their underwater jobs. And aquaculture is just one of 9 different industries we already have customers in. Ship owners will spend tens of thousands of dollars on underwater services every year on every vessel. Jobs normally done by local divers with a varying degree of attention to safety and quality. We can do these jobs with zero safety risk and at a fraction of the time and money the ship owner is currently paying. Bearing in mind that the global shipping fleet currently counts around 100,000 ships, that's a massive opportunity. There are other industries we intend to monetize over the coming months and years, like oil and gas, desalination, and offshore energy, just to mention a few of them. Since we started Nemo Robotics, we've shipped 200 robots to customers worldwide, and we reached $1 million in revenue in 2020. This is our first product, a really robust robot that can carry out a wide range of different jobs and carry many different payloads like sensors and cleaning systems. We have developed our own software with an advanced navigation module that shows us where the robot is in relation to a 3D model of the asset. In this case, it's a ship. And for the operator to tag points of interest in real time as they're doing the job. And as they're doing this, a report is being built in real time in the cloud. Once the job is done, the pilot can click a couple of buttons and send the finished report to all the stakeholders. Our solution can be operated from a centralized control center onshore, remotely to the internet. That means that a single, highly competent pilot can be doing an inspection of a ship in Singapore in the morning, swap to an oil rig in the North Sea next, and ending the day inspecting the fish farm in Chile, all without having to move from the chair. And we're not stopping there. By the end of this year, our robots will have reached a semi-autonomous state, permitting us to control a large fleet of robots, literally anywhere around the world, with just a small team of skilled remote operators. And next year, our robots will be fully autonomous and capable of a wide range of tasks, with very limited supervision from humans. This new technology is allowing us to shift our business model towards what we call underwater robots as a service. We charge a small setup fee that covers our costs, in addition to a monthly availability fee. But the bulk part of our revenue will be coming from usage and the reports generated on our system. Underwater robots as a service will help us scale much faster since we're no longer selling robots and put us on a path to more than $100 million annual recurring revenue in the long term. I'm obviously not alone in this venture. We have a stellar team of 11 people, including a doctor in computer science and naval engineering who's for the last 20 years have been building autonomous robots for sea, air, and land. A software engineer who has developed autonomous boats for the Spanish military and websites with millions of daily active users. And myself, well, I spent 15 years of my career at sea on some of the most advanced ships in the world, both in the Norwegian Navy and in the oil and gas industry. I'm Captain Roy Torgerson, the founder and CEO of Nemo Robotics. Thank you so much for your attention.
Hello, my name is Nir, Sierra's CEO. We develop intelligent vision products for the blue economy. The blue economy is huge and diverse with varied industries such as aquaculture, offshore oil and gas, and shipping. They all involve underwater operations that require cameras and depend on good underwater visibility to allow the operator to see well. Ship's hull, for example, is visually inspected in routine manner. And so are submerged oil and gas pipelines that undergo visual damage inspection due to the harsh marine environment. However, any diver or underwater vehicle operator will certainly find this view quite familiar, as poor underwater visibility is a common problem. In fact, it is a major challenge and it costs a lot. For example, one of the biggest challenges for fish farms is fish contamination and disease. Fish behavior and appearance are therefore monitored for early detection. But this is hard to do because the current monitoring methods cannot deal with poor underwater visibility. As a result, the aquaculture industry loses over $6 billion a year due to fish contamination alone. But what if we could see better? You could judge for yourself comparing the original and the enhanced videos on left and right. This is what you see with Sierra's real-time vision enhancement software. Our algorithm removes the water out of the image and reveals the true scene to the operator. The result is increased range of visibility, higher level of details, and reconstructed vivid colors, allowing to carry out activities as if visibility was good. All you need is simple software installation on the PC that receives the live video stream. The software is plug and play and easy to use. It can be operated in real time or for post-processing. It complies with any underwater camera and there's no need for hardware or special equipment. The algorithm works well with both natural and artificial illumination, so depth is not a limiting factor. Our technology gained global recognition from strategic players, organizations, and journals. Out of the many industries to which our product is a game changer, we have determined underwater robotics, aquaculture, and consumer cameras to be our target markets. We believe it will allow us to establish a strong and profitable business. The go-to-market strategy relies on two paths. Product sales through distributors or directly in case of big customers, and integration projects with players such as underwater camera manufacturers that will be able to sell their products with our vision enhancement on board. The pricing model is based on yearly subscription per camera, meaning recurring revenues to the company. Our product is being launched these days. Our first customer is Big Fish Farm in Israel. We have distribution agreement in Asia. There are several underwater vehicle manufacturers of different sectors doing pilots with us, and there is integration project with significant marine defense player. Last but not least is our committed and experienced team. El Canil, the chairperson of the board, has 25 years of experience in senior executive positions. Dr. Tali Tribitz, the CTO and founder, is an expert in underwater computer vision, and I have 20 years of experience as CEO and VP R&D in breakthrough technology companies. Think about all capabilities computer vision opened for us on land, and just imagine how it could change the blue economy. Thank you.
Hello friends, we are Spoolie. This is Knock Nevis, the largest ship in the world with a length of 458 meters. To put into context, Knock Nevis is taller than the Empire State Building, Eiffel Tower, and even the Petronas Tower. In general, ships are massive floating objects with hundreds of machineries and equipments on board. Here, you can see the anchor chain of a ship being examined and load tested. This anchor chain needs to be tested by a specialized third-party service provider. Next, you will see the communication equipment being checked by electronics expert to ensure that the ship can be tracked at all times and has communication with the shore staff. In the last picture, you can see the lifeboat of the ship that needs to be tested and always maintained in working condition. Because in the event of an emergency, the ship's crew's lives can be saved by the lifeboat. Like this, there are more than 300 jobs which needs to be done per ship every year. Also, there are close to 5,000 ports spread across the world. A ship is a moving object, and in just within a year, a ship can call as many as 35 to 40 ports. The servicing of the job cannot wait for the next port. For shipping company personnel, it's very difficult to have a perfect Rolodex of audited and capable service providers across all the 5,000 ports across the world. In addition, there is a Byzantine amount of paperwork and thousands of emails which needs to be processed to get these jobs done. It is also not easy to audit all the service provider. Now, this is not just a challenge for the shipping company, it's equally hard for the service provider. A service provider sitting in Colombo has no idea how to access job which is needed by a shipping company in Japan. They are also not sure what skill sets are currently in demand or what equipments they need to get certified on. In addition, there is a cash flow issue. Let me explain how the current working capital financing landscape looks like by giving you a small example. Ship requests a service for a service job, which is then handled by a shipping company employee, who in turn calls the service provider. And this whole process is so manual that it takes close to 15 days just to get the job started. Now, once the service provider starts the job, he has already incurred the expense of $20,000 or more. However, by the time he gets paid by the shipping company, it's close to 90 days. This is the nature of the industry in general and is affecting service jobs worth $64 billion every year. With Spoolify, we solve the problems for both the actors, the troubled shipping company personnel as well as the service provider. We are an AI-based service management platform with embedded finance feature. The shipping company personnel can now source for audited and certified service providers for any job at any port with the click of a button. With our collaborative workspace, they can coordinate with all the relevant stakeholders in the ecosystem through a single window. A service provider can get access to jobs even from his phone while sipping his coffee in the port of Shanghai or in Hamburg. So with Spoolify, a service provider can get paid even before they start the service job on the ship, hence solving their cash flow problems. Our business model is pretty straightforward. On every successful transaction, we charge 8% to the service provider. In fact, service providers are ready to pay more than 8% since they value both the jobs and the working capital financing which we provide. Now, from the TAM of $64 billion previously mentioned, even if we capture just 2% of it, we will be making a net revenue of $85 million and an EBITDA of $33 million in the medium term. This can be achieved by onboarding close to 3,500 ships on our platform and carrying out at least half of the 300 jobs which are required on these ships. In the long term, by capturing 4% of the market, we have the potential of having a net revenue of 200 million US dollars and an EBITDA of 80 million US dollars. Our solution is also able to scale into oil and gas, power, or any other heavy asset industry. In terms of traction, we have already onboarded 3 large shipping companies in Singapore, amounting to 156 ships, and are in advanced talks with several others. The ships will give us a potential gross service value of close to 5 million US dollars. We already have close to 250 vendors who can cover more than 120 type of jobs across major seaports in the world. We have also performed a couple of jobs through our platform and are in early revenue stage of our business. Now, we started the company in April 2020, and we have been able to onboard service providers and shipping companies fairly fast. The reason being, we are a very strong maritime team. I am Saurish Nandi, the co-founder of Spoolify, and the shipping company employee you saw in the previous slides, that was me. And I have been doing procurement-related tasks for the last 18 years. Also, others in our team like Dipankar, Inder, and Jason have deep roots in maritime. And together, we believe Spoolify is well on its way to disrupt the services supply chain, one ship at a time. Thank you.
Hi everyone, my name is Alina Hoon, and I'm the Program Manager here at Techstars Singapore. We have come to the end of the demo day, and we hope you're excited about the companies just as we are. Please head over to demoday.techstars.com to contact the founders directly, or feel free to reach me at my email address if you have any questions. Once again, here are the 9 companies in the 2021 class of the Eastern Pacific Accelerator powered by Techstars. Thank you for joining us here today.